Introduction to Cellular Manufacturing. In this video, we are going to see about the introduction to cellular manufacturing. Cellular manufacturing is the use of group technology ideas to workshop reconfiguration and shop ground layout design. The high profit of CM implementation is that a big industrial structure can be disintegrated into lesser subsystems of machineries are named as cells. These cells are dedicated to technique part families based on similarities in industrial requirements. Cellular manufacturing potential benefits can be improved the market reaction, extra reliable transport promises, reduced tooling and fixtures, and basic development. Flexible manufacturing systems, that is FMS. In this video, we are going to see about the flexible manufacturing system. Flexible manufacturing system, that is FMS, is an industrial system based on multi-operation machine tools, incorporating integrated computer control with associated support function of automatic material handling. It is designed to produce a medium part variety and medium production rate in the computer integrated manufacturing systems, that is CIMS. So the FMS is considered to be a subset of CIMS. FMS becomes necessary for producing parts with medium range production and flexible in manufacturing. Working of flexible manufacturing system. In this video, we are going to see about the working of flexible manufacturing system. The main components of a FMS are production equipment, support systems, materials hold method, buffer storing of parts, chip removal and washing stations, computer control system. Working of FMS. The fresh workpiece arrives as system from automated aided storage and retrieval system, that is ASRS, called loading of the work part. If the particular machine center is busy, the workpiece will be diverted to any other idle machine. For this, artificial intelligence is used. Normally, conveyors, automatic pallet changes, AGVs are used for handling system. FMS consists of several material handling systems that have to be synchronized with the machine operation. On completion of all machining operations, the workpiece enters the chip removal and washing stations. The cleaned workpiece enters the inspection station. Using a robot, the workpiece will be moved to the coordinate measuring machine, that is CMM. Here, the parts are inspected as per given specifications. After inspection, all accepted workpiece enter the assembly station. Here, the assembly of work parts is done. The assembled work parts will be transported to the storage racks. In FMS, a central coolant system supplies the coolant to various machines. The computer system is interfaced to the labor places, material handling system and other firmware components. The central computer coordinates the actions of the mechanisms to attain smooth general operation of the system. Advantages of FMS. FMS are suited with CIM. System reliability is increased. Manufacture flexibility is enlarged. It reduces the number of tools and machineries. Better management control. It is a faster reaction to marketplace variations. It will reduce the direct and indirect labor. Reduced inventory. Manufacturing lead time is reduced. Better and consistent quality. FMS has increased the machine utilization. Disadvantages of FMS. Due to better complexity and cost, an FMS also needs lengthier planning and improvement period than traditional manufacturing equipment. Startup is more costly. It is tough to position the component accurately and it needs more process time. Not economical for low production rates. Unemployment problem will arise. Flexible Manufacturing Cell, that is FMC. In this video, we are going to see about the working of Flexible Manufacturing Cell. Flexible Manufacturing Cell, that is FMCs, is the automatic machining is a wide range of various workpieces. They are generally active in one-off and small group manufacture as self-governing machining centers, but are often the initial opinion of FMS. Turning center built in by a gantry loading and unloading system and pallets for storing work pieces and other parts is a usual flexible turning cell. Flat machining centers with automatic tool changer, multiple pallets, innovative tool management system and robots to support access of the jobs to the machine also found a flexible machining cell. The system is organized by a PLC and a couple of private computers. Cells level design in FMS. In this video, we are going to see about the cells level design in flexible manufacturing system. Cells level design in FMS. For better understanding of the whole FMS and its various components, a FMS installed at Watt Aerospace in Dallas, Texas by Cincinnati Milacron is illustrated in video. 1. 5 Milacron 5-axis T30 CNC machining centers, 90 tools each. 2. 5 tool interchange stations, 1 per machine accepting tool delivery via chart. 3. 3 computer-controlled charts with wire-guided path. 4. Cart maintenance station. 5. 2 automatic work changers, 10 pallets each, with dwell load or unload positions with a 90-degree tilt, 360-degree rotation. 6. 2 substance analysis stands for on-requirement part check. 7. Check module with LK tool co.meter 4 microvector horizontal arm coordinate measuring machine. 8. Automatic part washing station. 9. Tall chain load or unload, tool gauge and calibration gauge stands. 10. Elevated computer room with DEC VAX A200 central computer. 11. Centralized chip or coolant collection or recovery system with dual flue. The FMS shown in figure is designed to produce a family of machined metal parts that can be manufactured with 3-axis vertical machining centers. 5 machining centers are required to meet the production demands. Frequently, a partially finished part will be removed from one fixture and placed on another in a different orientation for additional machining. The fixtures are delivered to the correct machining center cell by the computer-controlled cart or automatic guided vehicle, that is AGV. The material handling AGVs are also used to deliver tools from the setup and calibration area, that is 9 in the figure, to the tool interchange stations, that is 2 in the figure. From the tool interchange stations, tools are changed automatically on the machining centers to match the requirements of the parts to be produced. Finished parts still mounted to the pallets are delivered by the AGV system to the parts washing station, that is 8 in the figure, prior to inspection and shipping. To track the quality of finished parts, the AGV delivers machined parts to the coordinate measuring machine, that is 7 in the figure, for the automatic inspection or to the manual inspection stations, that is 6 in the figure. A centralized chip and coolant recovery system collects metal removed in the machining filters, a cutting fluid used in these cells. Designing FMS. The important decision in designing and developing FMS fall into 2 categories: initial specification decisions, implementation decisions. Initial specification decisions: types of parts to be produced, that is variety, process planning for these parts, type of flexibility that is required, type of FMS to be developed, type, capacity, specification of material handling systems. Design the control system, that is hierarchy of computer control. Implementation decisions: determination of layout of FMS, determine the number of pallets required, determine the type and number of each type of fixture and design of these fixtures. Specification of strategies for FMS. These decisions are taken after a thorough analysis of the above aspects to achieve maximum flexibility and efficiency.